I'm talking about the rooting systems, the things you don't see. But this is a characteristic of all our Banksias. They have a sinker root, a main sinker root, and they also have laterals coming off, so horizontal laterals and also laterals which go much deeper as well. It's called a dimorphic root system. There's two different main types. And off the laterals, you get other sinker roots coming off. It's essentially designed to spread out and put down to access groundwater or soil moisture at depth. And some of our shrubby species also have this dimorphic root system as well, so laterals and sinker roots. Now off these laterals in Banksias, this is where the cluster roots come off, or proteoid roots. In about the top 10 centimetres of the soil, this is where most of the phosphorus is gained from the soil in these proteoid roots. So if we look sort of top down, you're above a Banksia looking down, this is the spread of the roots. You can see these are the laterals going at least 4 metres, in some cases a lot more, out from the main plant. And then we've got the dots represent the sinker roots. So you can see it spreads out and then drops down these sinker roots to access moisture at depth. So if we look at a typical topography of the sandplain, we go from the low-lying wetlands or damp lands. Damp lands are a type of wetland. They're seasonally wet, seasonally dry. Again, you go up the embankment, a lower slope, upper slope, and up to the dune crest. The main tree species that are found in this system occur in different places in this topography, and hence implications for groundwater use. So we have the species which occur in or surrounding the damp lands, Melaleuca, Parisiana, Banksia littoralis, and these days the damp lands are drying out, so they're not getting that groundwater coming to the surface, and hence you're finding recruitment of species in the damp land itself. We come to Banksia licifolia, which only really occurs on the embankment edge and up the lower slope here. And then we have the co-dominants, Banksia tenuata and Banksia menziesii, which occur essentially everywhere except where it gets reasonably wet. So looking at this distribution, you could probably make some general comments about the ecology of these plants in relation to groundwater use. You could say that species which occur up here are going to use less groundwater because the groundwater table is much lower, and species down here are going to access more groundwater. And so you could say that there's a gradient from low to high groundwater use. If you think of drought tolerance, and summer drought tolerance in particular, you could say that these species down here rely on more groundwater, therefore are not very drought tolerant, whereas species up here should be drought tolerant. And to a certain extent, the physiology bears that out in Banksia trees. Shrubs, sometimes a bit of a different story, but if you look at the main Banksia species, that's true as well. If you analyse the deuterium content of the water in a stem and compare that to the deuterium content for the various sources of water that the plant might be using, essentially you come up with a model which says how much groundwater might be used. Banksia littoralis only occurs in these embankment areas on the Swan coastal plains. This one has got problems up in the Jarrah forest, in the riparian areas, and also suggests on the Swan coastal plain. It's called a obligate phreatophyte. These ones are entirely dependent on groundwater all year round. So they're restricted to areas where the groundwater level is quite shallow, and this represents groundwater depth. So in December, in the damp land itself, it was half a metre. It dropped to a metre in February in 1997. So in the embankment site, it is a drop of half a metre. If we look at the groundwater use, I believe that December there was a reasonably good winter rainfall year that year, and hence the groundwater levels were quite good in December. This suggests that certainly in midsummer, less than 50% of the water which it's using is from groundwater use, i.e. the rest of it's from soil moisture. So soil moisture and groundwater are very important sources of moisture for plants. And as you see, it's about 80% in December, drops in summer, and it increases about 60%. So, but it's still, that's quite a lot of groundwater that it has to use. If these levels start to drop over long periods of time and the groundwater levels start to decline, these species have got problems because they need a lot of water in the summer to survive. If they haven't got access to that reliable water source, you're going to find these plants becoming very stressed and ultimately they're going to die out. If we look at Banksia licifolia, again we're looking at the embankment site and just up a bit, the lower slope site. I don't believe it's obligate in the true sense of must. I believe it is dependent on groundwater for its survival, but does not only just use groundwater as well as sea. The coastal groundwater depths less than 8 metres, or historically used to do that. I'm not sure if that's true these days. Certainly they don't occur anywhere further upslope on the dune crest. They're restricted to this sort of location in the landscape. So again, we've got the same sort of data, December and February. So here there's a 1 metre drop in groundwater level that occurred. And if we look at the data, in the embankment site, a lot of groundwater is being used. At the lower slope side, about 60% is being used here. So it's using groundwater, but there's also supplementing it with soil moisture. It then drops quite substantially, about 20%. So as half a metre drop and a metre drop in groundwater, there might be some roots going down accessing groundwater. It's actually the fringe, it's actually not the groundwater itself, it's the capillary fringe. It's the saturated soil above the groundwater itself, which is probably using. But it's suggesting that it's switching from what might be called a reliable water source to one which is essentially going to dry out as the summer continues. So it transpires or uses lots of water, needs a reliable water source to survive. It doesn't have that. As the soil moisture starts to, as the groundwater starts to drop and the soil moisture starts to decline because we don't have the rain we used to in winter, and hence we're not having the moisture content at the end of spring, and in the summer it dries out entirely. This species is going to have issues. It's not going to have the reliable water source it used to have. So we look at the two co-dominants, and we've only got data for Banksia tenuata. These are faculty phreatophytes, uses groundwater but can cope without it. Inhabits all locations in the landscape, up from the dune crest, down. The data suggests for tenuata that it's about 40% wherever you occur. In these three locations, up here, no access to groundwater at all. Roots don't go 30 metres deep. It's using about 60% moisture from about greater than 4 metres depth. So it's switching between groundwater and soil moisture as it loses contact with groundwater. Its ability to switch between a good water source to one which is there and utilise that, and they're much more drought tolerant, these species. So if we look at some historical data of locations, we see that this represents groundwater, and you can see regionally it's declining. We are losing littoralis, decreasing distribution, significant decline in number of trees, but species like Banksias, which are quite drought tolerant, are actually increasing distribution across the landscape. So for the trees of Perth's Banksia woodlands, where they occur in the landscape is related to how they use the groundwater. And this has implications for the species water use during the summer months. If you can't survive the summer period, you're not going to survive at all. And rooting depths have implications for that. Thank you.